Hello everyone, my name is Ayush Bandari and today I'll be presenting our work, BrandNERD, a large-scale dataset and pipeline for brand name entity resolution. Named entity resolution or NER simply means identifying when different text strings actually refer to the same real-world entity. As you can see in the image, problems like identifying if Annabella Smith and Anna Smith with slightly different addresses are the same person appear in many domains. But our focus is on one of the most chaotic one, that is brand names in online auctions. That's where named entity resolution becomes important and very significant, where we have to go beyond exact matching and understand the context and similarity behind those brand names. Let's break down our problem we face. We began with data from an online auction platform containing over 40 million products. Our goal was to analyze bidding behavior, and for that, we needed accurate brand information. From these listings, we extracted nearly 400,000 raw brand names, but the data was not as clean as we expected. The brand names were ambiguous, some were misspelled, others were abbreviated, and many contained irrelevant words like Inc. or LLC or pharmacy, as you can see in the screen, that did not help us identify the brand itself. These inconsistencies made it difficult to track the bidding behavior or extract meaningful insights from the data. So before building anything, we looked for existing datasets that could help to obtain verified brand names, and we encountered a significant gap. There were very few open source datasets available, and the ones we found were either small or had limited entries. We also explored large datasets from US Patents and Trademark Office, who are responsible for trademarks, but they presented a different problem. They both contained service oriented and product oriented brands, while we only needed the product based brands. This mismatch left us with no readily available solutions, so we decided to build our own dataset by working with the messy data we had. But this led us to another challenge. What kind of algorithm should we use to process this noisy data? And there were many approaches like string similarity, web-based methods, context-aware algorithms, and even machine learning models. But each of them had their own set of trade-offs. Automated methods like string similarity algorithms and machine learning models are fast and scalable, but they often fail with short or noisy brand names. Like in the case of Delta, as you can see on the screen, with a small typo, it confuses the two variations of brand Delta and treat them as unrelated just because of a small typo. Manual methods, on the other hand, are accurate, but they are time consuming and impossible to scale when dealing with hundreds of thousands of brand names, which is our case. So, we needed a hybrid approach, one that combines automation for scalability with human review for accuracy. All of these challenges led us to our main contribution, that is BrandNERD. It is an open source dataset and modular pipeline designed specifically for brand name resolution. What makes it powerful is its scalability, flexibility, and openness. And it includes nearly 369,000 canonicalized brand names and over 60,000 validated brand names. We built it as a staged based pipeline where each step from cleaning to validation produces its own dataset that can be reused or improved independently. The system is modular, so other researchers can plug in new algorithms or modify existing steps without rebuilding the whole process. And most importantly, it is open source, meaning anyone can access, use, and extend it freely for research or practical applications. Now that we have the goal, here's how we built it. It has six major steps. It starts with collecting raw brand names from online marketplace listings. Next, we perform canonicalization, where we clean and normalize the names, such as removing special characters and other noises. Then we use similarity matching to detect names that likely refer to the same brand, that is, for example, Disney Inc. and Disney. After that comes validation, where we automatically check if a brand actually exists by performing web searches on major retail sites. We then perform aggregation, which merges similar or duplicate names into a single verified brand entry. And finally, the result is a clean, validated, and structured dataset ready for the analysis. The first step in our pipeline is data collection. We scraped publicly available product listings from a large auction marketplace, which resulted in 394,542 unique raw brand names. These names came directly from the listings. No product description were used, no model numbers or categories were used. By working only with the brand strings, we tackled the hardest case of entity resolution, that is, identifying brands solely from the text without relying on product descriptions or metadata. This ensures the dataset and pipeline can be applied to any marketplace data in the future. The second step in our pipeline is canonicalization, which means converting any surface variations of a brand name into one standardized form. We use a two-stage process in this step. First is rule-based cleaning and the second is normalization. During cleaning, we remove unnecessary elements like punctuation, legal suffixes such as LLC or Inc., and non-alphanumeric symbols that often appear in scraped data. After cleaning, normalization ensures a consistent format, for instance, converting Apple Inc. or uppercase Apple to simply Apple. Through this process, we obtain 368,703 canonical names, covering about 93% of the total dataset. This step helped us eliminate duplicates and prepare the data for deeper matching tasks like handling typos or near duplicates in later stages. Once the names were standardized, the next step was to find which ones likely refer to the same brand. And there comes our third step, that is similarity matching, where we compare brand names to detect pairs that likely refer to the same entity. We experimented with several algorithms including Levenshtein distance, Zaro-Winkler similarity, phonetic matching, and cosine similarity using text embeddings. Each method captures similarity in a different way. For example, Levenshtein counts how many edits it takes to turn one word into another, while phonetic matching groups names that sound alike. After testing them on multiple brand pairs, our results showed that Zaro-Winkler similarity performed the best. It was the most accurate in identifying when two names Using the Zaro-Winkler approach, we identified over 782,000 pairs of similar brand names with a similarity score greater than 0.9. This step was key in automatically detecting typos, duplicates, and even naming patterns across the dataset. For instance, it grouped together variations like CatJack and CatJack brand, allowing us to merge them efficiently in later stages. With that foundation, we are ready to validate which of these names represent real existing brands. And the fourth step is validation, where we confirm whether each brand actually exists in real world. To do this, we developed a browser automation tool using Selenium that performs web searches for each brand name. The tool uses the Brave search engine and checks for brand presence on major e-commerce platforms like Amazon, Walmart, Postmark, etc. This process allows us to automatically confirm if a brand is real without needing paid APIs, which will be too expensive for such a large dataset we have. For instance, as you can see in the slides, our system validated the brand Olivia Pratt by confirming its presence on multiple e-commerce sites. This helps us automatically separate genuine brands from noise. But as we will see in the next slide, not every case is so straightforward. So far, we have searched 309,581 brand names, which is 83% of canonical brands, and 72,303 brands have been automatically validated, which is about 20% of the canonical brands. However, the validation process is still ongoing as we continue to verify the remaining brands. While most brands can be validated automatically, some names remain ambiguous, and this is where automation alone is not enough. For example, the brand Genusi, as you can see on the screen, could not be automatically confirmed as genuine because its search result did not provide clear evidence of a real brand presence. These unresolved cases led us into our next step, that is aggregation, where human review helps finalize the brand resolution. In the aggregation step, we merge the similar brand names that refer to the same company, not just the identical ones. For example, we might merge Apple Inc. and uppercase Apple into a single canonical entry, or combine Amazon Basics and Amazon under a one brand name that might be Amazon. We use a web-based review interface that displays the suggested matches, and human reviewers confirm or reject them to ensure the accuracy. So far, we have resolved around 32,000 brands through this process, and the work is still ongoing. At this point in the project, we have completed half of the pipeline and made significant progress toward full resolution. The steps, validation, aggregation, and resolution, are still ongoing as we continue refining and expanding the dataset. The complete dataset is already available open source, and you can access it on our GitHub repository shown here. We update it regularly as new brands are processed, validated, and merged, making it a continuously evolving resource for researchers and developers. Looking ahead, our goal is to fully validate and resolve 100% of the dataset, ensuring every brand name is correctly identified and linked. We plan to extend the pipeline beyond brand names to also include models and products, creating a more complete understanding of how items are represented across marketplaces. We will also explore new techniques such as graph based clustering, new algorithms, and crowdsourced validation, all aimed at improving both accuracy and scalability. Our goal is to keep BrandNERD growing as a community driven living resource that supports continuous research and collaboration. You can access the BrandNERD repository using the QR code shown here or directly through our GitHub page. If you would like to collaborate, use the dataset, or learn more about our work, feel free to reach out to the email addresses shown in the slide. Once again, thank you for your attention and interest in our work.